Hey, what's up, you guys? This is Miss Keener on YouTube, and this is Unit 4 Test Review FRQ number 2, 2018. Click the link in the bio for nothing. Just kidding. There's nothing in the bio. Okay, here we go. I'm just trying to be a better YouTuber. Here's this wonderful function, and we have this information below. You may want to, should we do a little cheat sheet, a little chart here? F prime, F double prime. This is a good idea to put on your test. So if F double prime is positive, then we know the first derivative, I start from the bottom and work up. And that would be concave up. So when the second derivative is negative, F prime is decreasing and concave down. And this is really a second derivative chart. When it's 0, what's happening here at F prime? We have a max or min, and then the original function of a POI. Okay, that's only for the second derivative though. If the first derivative, the first derivative, we already had a whole test on the first derivative. We know that when it's positive, the function's increasing, negative, decreasing. We already know that. Okay. A, ready? Determine the intervals of increasing and decreasing of F. Justify your answer. The worst part about this are the sentences that we have to write. They kind of get annoying, but here we go. We have to do it. So F is, I like to start by repeating the question, just like in elementary school. That's how you write a complete sentence. So determine the intervals of increasing. We say F is increasing on, we're going to write that. And the reason is because, well, why is something increasing? Because the first derivative is positive. And you can write is positive, or you can write greater than 0. Okay. Now, where is F is increasing where the first derivative is positive? So what do we have here? We have positive, and we have positive. And this table is just written a little bit differently. It's in, what's this called? Inequality notation instead of the intervals, like with the parentheses and brackets. So this says F prime is positive when X is less than -1. So that's what we're going to write down. X is less than -1. And then the first derivative is positive when X is greater than 2. Okay. X greater than 2. I guess we could just write an X here, make it a little easier. All right, we're also doing decreasing. Here we go. F is decreasing on blank because F prime of X is less than 0 or negative. So F is decreasing when the derivative is negative. And the derivative is negative at all of these numbers. And there's no gaps here, right? -1 to 1/2, but then also at 1/2, and then 1/2 to 2. So we can just say from -1 to 2. And I'm just copying the inequality notation because that's what was used here in the table. Review, yes? Okay, determine and classify all xy's of relative extrema or extrema. What the heck? What is extrema? What does that mean? Yeah, those are max and mins, extreme points on the graph, max or mins. So max or mins occur when the derivative is 0, but not just 0, it has to change from positive to negative or negative to positive. So if the first derivative is changing from positive to negative, what's happening at -1? What extrema is that? A maximum, and then we're changing from negative to positive. So what's happening at 2? A minimum. Okay, you ready for the sentence? Here we go. This is where the time lapse should come in. Do, 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 do. And it goes real fast, but it's not. This is just a live video at G204, Shadow Hills High School. F has a relative, I lost focus. What are we doing? A relative max at X equals -1. We need a reason. Changes from positive, think of something funny, think of something funny, think of something funny, to negative, see? Period. F has a relative minimum, abbreviations, at x equals 2 because f prime of x changes from negative to positive. Okay, I think this was our Unit 2 test. So Unit 1 was limits, Unit 2 was this, where we didn't even know how to take a derivative, but we were talking about the derivative. And then Unit 3 were all the derivative rules, and now we're in Unit 4, which is introducing the second derivative. Okay, so A and B review, here we go. Determine the intervals of concavity of f. Justify your answer. This is f is concave up like a cup. Concave up on blank because, and what's the reason for concave up? F double prime is positive, or we say greater than 0. F is concave down like a frown. Concave down on blank because the second derivative is negative. All right, let's see here. F is concave up when the second derivative, so second derivative now we're looking here, is positive, but our answers are going to be the x values. So from x equals 1/2 to 2 to 2 to all the x's greater than 2. So we're going to say for all the x's greater than 1/2. Do you agree? You could also say from 1/2 to infinity. That means the same thing. And f is concave down for all the x's less than 1/2, or from negative infinity to 1/2. Okay, that should have been easy, but maybe the sentence frames you needed some help on. D is some mathy math, and I hope we have time to finish 3. But here we go. You ready? Determine the values of A and B in the equation of f. Show your work. So the first step is we need to find the first derivative. So we need to find f prime with the a's and b's, okay? Because we know something about the derivative. We know the derivative is equal to 0 when x is -1 or when x is 2. So we're going to use that information to find A and B. Are you ready? Here we go. What's f prime? What are we going to do here? The derivative of 2x to the 3, what's that going to be? 6x squared. Okay, the derivative of a to x squared will be 2ax. And the derivative of bx, what's the derivative of bx? Just b. Fantastic. Okay. Now I recommend finding the second derivative right away. This will be easier. So the second derivative, what's the derivative of 6x squared? 12x. And the derivative of 2ax? 2a. And what's the derivative of b? 0. Okay, the table tells you something about the second derivative. It tells you the second derivative is 0 when x is what? No, second derivative. What's x equal to when 1/2? Cool. What can we find now? What can we find? Solve for? Solve for a. So this info we got from the table. Okay, we got that the second derivative of 1/2 equals 0. We got that information from the table. So now let's find a. What's half of 12? 6, and we got to move that to the other side by subtraction. So subtract the 6 and then divide by 2. What's a equal to? -3. All right, now that we know a, what should we do with it? Plug it in over here. Now what do we know about the first derivative from the table? Okay, when x is we have a choice. You can use either one and you're going to get the same answer. Isn't that freaky? Freaky. So do you want to use -1 or do you want to use +2? Okay. All right, so what did I do? I put 0 in for the derivative. I put a as -3. And x, you can use either one. It's so weird, but we'll use 2. And now we're going to find b. So 6 times 2 squared. 2 squared is 4, and you have to do the exponent before you multiply. So 6 times 4, 24. And then 2 times -3 times 2. 2 times 3 is 6, times 2, -12. So here we are, 24 minus 12 is 12 plus b. So what does b have to equal? Excuse me, -12, yeah? Okay, we have time. We have some time to do 3. Ready? Get set. Find the derivative. You tell me, do you want to use the product rule? Yes, yes. Not do you want to, you have to. I was going to say distribute, but if we distributed, then we'd have to use the product rule for this and for this. We don't want to do that. So let's use the product rule. Okay, ready? Get set. FG prime plus GF prime. So F is the entire parenthesis in the front. G prime, what's the derivative of E? E, good. Oh, okay. I will fix that. I'm still recording. Do the product rule. All right, the spacing's a little weird on this one, you guys. Am I wasting time? FG prime plus G, e to the x, F prime. So the derivative of x squared minus 2x. 2x minus 2. Okay, that's our derivative using the product rule. And what does B say? Find f prime is 0. Okay, what are we doing? We're just plugging it in? It's like there's a trick. What's the trick? I think the trick is find the right answer. Oh no, it froze again. Okay, plug in 0 to the... Oh look, you can see my pencil. Plug in 0 into this derivative. Okay, we need a final answer and we need it to be correct. We have a -1 in the front. Do you agree? Plus, what's e to the 0? It's 1. So what's -1 plus -2? -3. Need to be able to get the right answer on that stuff. Find f of 0. What are we going to do there? 0 minus 0 minus 1. E to the 0. What's f of 0 equal to? -1. Okay, this seems too easy. I'm concerned. Write the equation for the line tangent to the graph of f at x equals 0. Okay, what do we need for a tangent line? A y value and a slope. Do we have that? Y minus y1. What's the y value? So it changes to y plus 1 is -1. That's the y value. Equals the slope. What's the slope? -3. Found it over here. Slope. And times x minus, what's the x value? 0. No tricks, just can you get the right answer? Okay. So that's it. You can solve for y if you want to. Usually we don't, but since this is a 0 here, yeah, it's like, okay, I can solve for y. But you don't have to. What do I say at the end? Smash that like button and make sure you subscribe.